Good morning, everyone here, and good afternoon, people from Zoom. Thank you very much, everyone, for coming and celebrating this day, and allow me to present my research in the PhD program. And thank you, my supervisor and committee and professor. My thesis title is Foodborne Bacteria in Cambodia, Mid-Value Chains, and I emphasize on the risk of salmonella in chicken and pork from traditional market to household consumption. So during the entire presentation, I will bring you from the introduction to the aim, to the material and method, result and conclusion, until the recommendation. And this thesis is a compilation from 3 papers. So I'm not going to present paper one by one, but it's combined together because all of this work is combination of these 3 papers. Yeah, Professor Anders have mentioned some about salmonella, that is a very important cause of human salmonellosis. That, for example, they have diarrhea, stomach pain, fever, nasal or headache, and more than this. Economic loss daily per year, like that he had mentioned. So around 200 different types of foodborne disease cost around 600 million per people per year. That is the review from WHO. Not only salmonella, and impact is higher in less than 5 years old children. And it's comparable. It means that the foodborne disease is high comparable to HIV, to those tuberculosis, malaria. So it's serious. And major foodborne pathogen he also mentioned, but one of them salmonella, and the global cost nearly is 230,000 deaths annually. That is from the WHO. So it's high, very high. So I read a little bit on what is known about salmonella in Cambodia. So we have very little data known in Cambodia about the incidence of salmonellosis. Therefore, we have the foodborne outbreak. We have reported the foodborne outbreak as general, and like specific only diarrheal symptom, not really salmonellosis or other pathogen in all cases. And salmonella has been reported from chicken, meat, and pork recently, and this for several years ago is 88%, is very high, but in my study it's lower than this. And in chickens it's about 23%, and very few papers published regarding foodborne bacteria in the country. So we haven't much data and also have little research on that. So here is Cambodia. You see the world map, and here in Southeast Asia. I would like to bring you to the value chains of pork in Cambodia, one example, and it's similar to chicken value chains as well. And we have farm, so also chicken also have farm, and we slaughter the animals, and at the slaughterhouse there is a risk of contamination from fecal, from the floor, from other sources, from equipment. Like here you see the picture here. And transportation, also one part of the contamination, and to the traditional markets. Temperature, we have set in the tropical temperature 29 to 30, so that is the good temperature for growing of bacteria, not cold like here. And environment, shop, retailer, practice, and equipment at the market, like you see here. This is one of the market in Phnom Penh, but not all every around the country are bad. But we select one that is not good and we use as example. Consumer, so some people have different susceptibility to pathogen, to bacteria, to salmonella, and age and consumption little or much, and cooking practice at households also the problem. So our scope is to work from this. We did the risk analysis of salmonella from traditional market to household consumer by choosing a food named salad, but it made from chicken salad and pork salad to use as a model for cross-contamination. So the framework is from Codex Alimentarius. I think most of you are aware of this. Content risk assessment, risk management, and risk communications. Regarding the risk assessment, we have other risk assessment from OIE, but we focus on the risk assessment from Food and Agriculture of the United Nations and WHO that concern more on food safety. We have hazard identification, hazard characterization, exposure assessment, and risk characterization. So in my entire material and method and result, I will present you all for this 4 steps, what I did in each paper and combine it. So I move to the aim of the studies. We have a few aims, but the overall is to estimate the risk of salmonellosis to consumption, contaminated chicken and pork salad prepared at Cambodian households. So there are different practice, not the same in everywhere. So we did the survey and estimates. So the specific objective is to determine the prevalence of salmonella in Staphylococcus aureus and with markets. We also did sample in supermarket and traditional market and measure the quantity of salmonella cross-contaminated from chicken and pork during handling and preparing the chicken and pork salad, and identify common chicken and pork salad preparation practice and consumption pattern in the country. We did the survey on that, how many people eat and frequencies, and estimate the daily and annual incidence of salmonellosis resulting from eating these foods. So here is the country. We divide into provinces. I'm not sure here is province or what, but the country, the province, district, and commune. So different color is the different province of my country. And here is the red for study 1 and study 3. We infer and we analyze the whole 25 provinces. And for study 2, in paper 2, we did survey only 4 provinces, and one Phnom Penh is capital city where I live and where my institute is. So here is my model framework of the QMA that we did. First, hazard identification. We did the stakeholder meeting. Those contain experts around the country who is food safety, and including all of my supervisor here over there, and we mentioned it in paper 3. 2, hazard and characterization. We get the data from the paper, the number 1, and we survey on salmonella and stuff. Which one is higher than we select salmonella for this assessment. And third is exposure assessment. We did survey on consumption rate and practice this, and did an experiment on how many salmonella cross-contaminate from it to reduce it. And for the analyzed data, we have number 4, that is risk characterization. We combine this result from 1, 2, 3, and also the data from literature using Monte Carlo simulation, stochastic model, and in at-risk software that is in Microsoft Excel. So I briefed a little bit on microbiology part that I did on finding Salmonella and Staphylococcus. So we did sample collection from market, and we did homogenized meat, and we did totally 3 to 400 grams of chicken, and totally 200 for sample each chicken and pork. And for Salmonella species, we only identify species, not until serotyping or strain of Salmonella, because like Professor Andrea mentioned that almost all of the Salmonella is harmful for public health, and also the review from the risk assessment of the WHO that any Salmonella are risk for health. And we did most probable number of Salmonella to quantify the number of Salmonella using the reference mentioned here. And for staff, we did the enumeration and detection of Staphylococcus, coagulant positive Staphylococcus and Staphylococcus aureus using the ISO method that I mentioned here in paper 1. And his detection during my lab work. For exposure assessment, we have two main parts that we did the activities. We focus group discussion with the household from 4 provinces that I mentioned in the map, that we select 93 households and ask them how they practice from buying meat from market until preparing the chicken salads. And data on preparation and consumption frequency and amount they eat. So I remind you that this food is very popular in my country. Like here, this salad is also popular, but we have a little bit different kind of preparation method. So here is the 4 trees that we have model step, and we have input parameter that we map for risk analysis, and until we get the probability of illness caused by Salmonella. So I can only brief you because time is not much for us. You can ask later. For model, we have Salmonella in meat from market, household, cross-contaminate, and consumption. 4 main points. And for input parameter, we have prevalence and concentration that we did find in the lab. We have storage temperature, that is the average from the country's autofocus, and the duration of storage also cause the bacteria to grow. Concentration after bacteria grown due to contamination, from time to buy and from time to cook, and some probability of some cross-contaminate that we did experiment from our food. I cook and we measure the meat, measure the Salmonella in the ready-to-eat salad, and concentration in the salad, quantity consumed per meal, frequency eating salad per meal by people in different age group. Actually, we should have more than age group, but there was a limitation of the data available to support the analysis, so we can only the age group. So I move to the result. For the result, I also mapped from 1, 2, 3, 4 as a model QMOA. That we did this during the hazard prioritization workshop, and you see my supervisor here, and also the project from international, the researcher from International Livestock Research Institute, and researcher from local from us, Ministry of Health, WHO, FAO, that time, and academies and animal health officers over there, and we most experienced in what is the main problem in food safety in the country, and we provide input. they provide input, but most of the design is from us. So we focus on the traditional market because this is the point that more to concentrate at this time. Maybe in the future it's something else, or maybe in the past it's something else. And meat, we choose meat, chicken, and pork because they are most consumed and most popular than other meat. And pathogen also, we have data and idea from all of them that salmonella and staph is the most common case reported for the foodborne pathogens. So we use this tool and we did survey. And food model, we discussed that what is the food that most likely to cross-contaminate, because most of the food in our country is cooked food, so most bacteria, virus are killed, but here is one of the easy to cross-contaminate and stochastic model. So we trying to collect most detail of the data as we can to combine and to get the most accurate data and risk outcome that we want. So second is hazard identifications. We survey on salmonella and staphylococcus, but we found salmonella was significantly higher than staph. So I pick up the salmonella for this analysis. And we are not present here stuff, but you may want to see the thesis. And the chicken meat is 42, almost 43%, and pork is 45%. As I saw in the literature, about 88%, but this is a way in particular area, but here is the whole country, 25 provinces. And here is the quantity, MPN, most probable number of salmonella per gram, and its average is 16 and 17 in porks, so it's also quite high. And this can, if you see the dose, it can cause a disease as well. For exposed pool assessment, I have 3 points that mentioned here that is already mentioned some about that common practice from household, and we get that data to design an experiment in 4 scenarios from the very good practice to the very bad practice, that we get this idea, this data from the household, not from our idea, but from the people practice like this, and we categorize 4 scenarios in, and we will see in these papers. And I did in myself in experiment in chicken, but we use data from Singh et al. Another paper that cooks the boiled pork that is quite similar and almost same procedure for preparing chicken salad in Cambodia as the data, and the design is also similar. So here is the common practice. I'm not sure we need to read all, but the storage process after buy to raw, and sequence of washing vegetable and raw. So the important thing is like washing vegetable first and washing chicken or carcass first. So which one is the most factor that most likely to get salmonella from meat to food? Because more salmonella in meat. But we also have measure in how they wash hand, how they wash equipment, how they boil chicken, how they wash equipment after preparing, and wash cutting board after cooking the salad. So I move to this result from the experiments on cross-contamination. According to the data that we get from household, that we scenario 1, 2, 3, 4 was vegetable first and use same utensil, was vegetable first and use different utensil, was meat first and use same utensil, and was meat first and use different utensil. So the highest then we found is was vegetable first and use the same utensils. So they was, but the same equipment they use, that means the salmon lab still exists in the equipment they use, so it still stay there and keep contaminate to the food that are ready to eat, to the salad that ready to eat. So it's from the this was very good, that doesn't contaminate at all that we found. And here is the consumption pattern. We can categorize consumption from eight group time per month, and average consumption amount gram per meal per person. So I can summarize for you that it's about 0.8 time per month that people in my country eat chicken salad, and 0.9 time per month we eat pork salad. And here is the independence data that they eat either pork or chicken salad. That is the answer from them. And for the amount gram per meal per person is 141 and 124 for pork and 130 for chicken and pork. Both, I mean, they can the answer either eat pork or chicken salad, both is mixed. Yeah, I highlight here. So here is the risk characterization. Yeah, the main point that I'm going to inform you and present. Like we have categorized to 8, like I informed you earlier that we cannot do more than this because of the limitation of data. And in summarize, all age that almost 4 people per 10,000 like at risk or get sick because of salmonellosis per day by consuming the salmonella, the chicken and pork chicken salad as above mentioned in our experiment that habit from the people that we interviewed. And more than 1 people among 10,000 get salmonellosis, and either pork and chicken salad is about almost 5 people get sick of salmonellosis. So it's a daily incidence, so it's high. And let me bring one more point, that is adults. So adult is the most common age that they eat more food, so they have more at risk of this salmonella. Yeah, like my age. When I'm in my country, I saw like this salad. So for the annual incidence, we have 1 case per 100 that we analyze. So we have about 11 person consume chicken salad at risk for salmonellosis per year, and 4 person consume pork salad per 100 per year that were at risk of salmonellosis. And most people who eat chicken and pork salad were 14.5, so they are more eating both things. And here is the sensitivity analysis from our study. We combined all the data that what are the factors that most influence on the risk. And we have a probability of cross-contamination from contaminated in scenario 3 that we did the experiment. Let me take some time to explain this. Like we get the data, the idea from household. They are most practiced like this scenario 3. So they consume most chicken and pork salad likely in the scenario 3. So these are the most factors that they are more likely to get salmonella to their stomach, to their daily food. And the second is prevalence of salmonella from market. So traditional market in our country is also playing important roles for the spread of salmonellosis to human. And the third is probability of cross-contamination in scenario 1, also part of the important. But the fourth and the fifth also the factor, but the three above is more harmful. So I bring you to the conclusion. We have several food safety concerns related to animal source food in my country, and we have foodborne bacteria that cause very high significance. If we think that only diarrhea is not serious, but if we eat every day is serious, it causes many effects. I think you already aware of that. Practice is enabling the transmission of foodborne bacteria. Yeah, practice is important. Like here we are trying to keep hygiene as we can. And there is a significant risk of consumer in Cambodia contracting salmonellosis after eating chicken and pork salad. And the result obtained guide the policy to develop the guideline and intervention aiming to improve food safety. So I have this in the next slide that we did already. This result led to the low cost intervention at the market to reduce the salmonella, and this my teacher. And the policy brief we published online from International Livestock Research Institute website. And we also submit to our government that this is the research finding, this is the result. Please use our result. So hopefully we can reduce the salmonella. And from the result, we strongly intervention to change the practice from market to household. And here is one of the picture I pick up from the intervention that we did already. But here in the thesis is the recommendation. We change table surface, we change apron, we change disinfectant, washing, detergent. So this will have to reduce most of the salmonella from the retail shop. And we found it really reduced because we did already, but in the thesis is a conclusion. It's a recommendation, but we did find ourselves that we reduced it. Yeah, thank you, and acknowledgement to all of this, and Swedish University of Agriculture that provide me the place to study, and BVF, and my home institute is National Animal Health and Production Research Institute, and Ministry of Agriculture, and also this Center for Livestock Development that co-partner for the research of these projects. And this study is under Safe Food Fair Food Project for Cambodia, funded by USAID, running by University of Florida, and implemented by International Livestock Research Institute, ILRI. And also co-funding me to study One Health, CGR One Health initiative, and this Fred and Dr. Singh is also the important person in the research work that they have to design and consult me. And very respectful my supervisor team, like here Professor Bukwis, Dr. Hung, Professor Johanna, Delia, Christina, and Dr. Stuart, who is my director in my home country. Thank you very much.